Exercise 7.1, sixth question. In figure, AC is equal to AE, AB is equal to AD, and angle BAD is equal to angle EAC. We have to show that BC is equal to DE. So, given AC is equal to AE, AB is equal to AD, angle BAD is equal to angle EAC, to prove BC is equal to DE. Look here, BC is equal to DE. BC is equal to DE. That means we have to identify two triangles in such a way that BC and DE are one of the corresponding parts. You have to identify two triangles in such a way that BC and DE are one of the corresponding parts. So, what you have to do is consider a triangle BAC and EAD. Triangle BAC and triangle EAD. In triangle BAC and EAD, BAC, AB is equal to AD. AB is equal to AD is given. Then AC is equal to AE is also given. AC is equal to AE is also given. AB is equal to AD. So, these two are the corresponding sides of these two triangles, and another pair of corresponding sides is AE is equal to AE. So, what we need is, we got two sides, two pairs of corresponding sides are equal. That is what we proved. We need an included angle. So, included angle of these two triangles means this is the included angle of first triangle and this is the included angle of the second triangle. But it is given that these two angles are equal. For getting it totally, we have to add this part to each. So, we need angle BAC and angle DAE are the two included angles which we have to prove equal. But it is given that angle BAD is equal to angle CAE is given. We have to get this fully. So, for that we have to add the small part, that means angle DAC to both sides. So, angle BAD plus angle DAC is equal to angle CAE plus angle DAC. We had added the same number to each side. So, angle BAD plus angle DAC means it is angle BAC. This means that angle BAC is equal to angle DAE, the total angle. So, what is the conclusion? These two triangles are congruent using SAS criterion. So, what we can write is triangle BAC is congruent to triangle DAC using SAS criterion. Two sides are included angle. This implies that BC is equal to DE. BC is equal to DE using CPCT. This is the answer. Here, for making it as included angle, we have to add the small portion to each of these angles. Angle DAC to each of these angles. So, we got it as included angle. So, proved both these triangles are congruent using SAS criterion. So, we can say BC is equal to DE using CPCT. Next question. AB is a line segment and P is its midpoint. D and E are points on the same side of AB such that angle BAD is equal to angle ABE and angle EPA is equal to angle DPB. I have marked this here. These two angles are equal and these two angles are equal. What we have to prove is these two triangles, triangle BPE and triangle APD are congruent, and we have to prove AD is equal to BE. So, to prove triangle DAP is congruent to triangle EBP and we have to prove second one as AD is equal to BE. After proving the first section, we can say AD is equal to BE using CPCT. So, what is given is P is the midpoint. So, AP is equal to BP. That is one side of each of this. Then, one angle is given, angle A is equal to angle B is given. What about the other angle? Other angle means it should be APD and BPE. That means this part is missing. We have to include that part also along with that. For that, we have to already given these two are equal. So, we can add this to both sides. So, we can write one by one. What is given first is AP is equal to BP is given and angle BAD is equal to angle ABE, that is also given, and last one given is angle EPA is equal to angle DPB. So, we need to get full angle. For that, we have to add this angle EPD on both sides. So, angle EPA plus angle EPD is equal to angle DPB plus angle EPD. So, angle EPA plus EPD will give angle APD. This implies angle APD is equal to the second section DPB plus this will give angle EPB. Angle EPB. Therefore, triangle APD is congruent to triangle BPE using ASA criterion. Two angles and included side. If these two are congruent, we can say AD is equal to BE using CPCT. This is the answer. So, what we have done is we have proved both these triangles are congruent using ASA criterion. To getting the last angle, we have to add this part to on both sides of this part to both these angles. So, we are getting it fully APD and BPE. Then finally we have written AD is equal to BE using CPCT. Next question. In a right triangle ABC, right angled at C, M is the midpoint of the hypotenuse AB and C is joined to M and produced to the point D such that DM is equal to CM. Point D is joined to B. We have to show that triangle AMC is congruent to triangle BMD. So we have to write the given things. So given DM is equal to CM is given. Then BM is equal to AM is also given. Then what is given is angle C is equal to 90 degree is given. So we have to prove all these. So after writing the given, you have to write what to prove one by one. So first one is triangle AMC is congruent to triangle BMD. Triangle AMC is congruent to triangle BMD. How can you prove that? So already two sides are given, isn't it? So first one, MD is equal to MC is given. Second one, MB is equal to MA is given. What about these two angles? They are vertically opposite angles. So, but we should start from the corresponding parts. See, if we start from A, we should start from B because this is the ending of this line, single line one. So, angle BMD is equal to angle AMC, it's vertically opposite angles. So what we can conclude? Triangle AMC is congruent to triangle BMD. We need all these results for final proving the fourth one. So I am keeping the question there, I am going to rub this. So what we have taken is, this is given, BM is equal to AM is given and DM is equal to CM is given and the included angles are vertically opposite angles. So what we can conclude is these two are congruent using SAS criterion. Then second one, angle DBC is a right angle. Angle DBC is a right angle. How can you prove that? Angle DBC, this is already given as right angle. We have to prove B is also a right angle. For that, actually what we are using is, we are going to prove BD is parallel to AC. We are going to prove BD is parallel to AC. How can you prove BD is parallel to AC? We can say these two angles are equal using CPCT in 1, but these two are, marking is different. These two angles are equal using using CPCT, but this acts as alternate interior angles. These two angles are equal. So angle CAM. Angle CAM is equal to angle DBM. Angle DBM. These two angles are equal using CPCT. So we can say BD is parallel to CA using alternate interior angles are equal. angle CAM is equal to angle DBM using CPCT, but these two acts as alternate interior angles because AB as a transversal. So, BD is parallel to CA. After proving the parallel condition, what we can say is B and C are interior angles on the same side of the transversal. Here we are taking BC as the transversal. Angle B plus angle C is equal to 180 degree. The reason is co-interior angles are supplementary, or you can say interior angles on the same side of the transversal. Interior angles on the same side of the transversal. Are supplementary. Since angle C is equal to 90 degree is given, we can write angle B is also equal to 90 degree. I will explain this once again. These two angles are equal using CPCT because we have already proved triangle BMD is congruent to triangle AMC. So, using CPCT, angle DBM is equal to angle CAM. So, we can say these two sides, that means BD is parallel to CA using alternate interior angles are equal. If these two sides are parallel, angle B and angle C are co-interior angles or interior angles on the same side of the transversal. They are supplementary. So, angle B plus angle C is equal to 180 degree. Already angle C is given as 90. So, angle B is also 90 degree. Next, what we have to prove is triangle DBC. I will draw that once again, DBC. Triangle DBC, in which B is 90 degree, is congruent to triangle ACB. ACB, in which C is 90 degree. So, any common side here? Yes, BC and CB are common. So, if you want to keep one over the other, you have to turn and keep. So, BC is equal to CA common. So, we got one side. Any other side? What about BD and AC? BD is equal to AC using CPCT in A, first one triangle AMC congruent to triangle BMD. Using triangle AMC congruent to triangle BMD, we can write BD is equal to AC. So, we got two sides, unincluded angle is given, angle B is equal to angle C is equal to 90 degree. So, what we can say, triangle DBC is congruent to triangle ACB using what? SAS criterion. Using SAS criterion, what we can say is these two triangles are congruent. These two sides are common, that means BC is equal to CB and AD is equal to AC using 1, and angle B is equal to angle C is equal to 90 degree. So, using SAS criterion, we can say triangle DBC is congruent to triangle ACB. Then the last one is CM is equal to half of AB. Can you conclude CM is equal to AB? Can you conclude CD is equal to AB using CPCT in 3? Using CPCT in third one, that means triangle DBC is congruent to triangle ACB. we can say AB is equal to CD or CD is equal to AB. And CD you can write as DM plus MC. DM plus MC is equal to AB. But it is given that DM is equal to CM. So, instead of DM what you can write? CM plus CM is equal to AB. Why? It is given that DM is equal to CM. So, 2CM is equal to AB. So, CM is equal to half of AB. This is the final answer. CM is equal to half of AB.